Hey guys, it's time for math. I know we did some math practice this morning and we are doubling up and we are doing math again. We are not behind or anything, but we're trying to kind of do some practice. You know, this morning we talked about some skills that, the fractions they were this morning, some things that we haven't done in a while. And we still, though, have to keep going with our lessons that we haven't done yet. And guys, we only have Friday is our last new skill that you will learn, okay? After Friday, we are strictly reviewing only, okay? So we are definitely coming to an end here with our math. You guys are almost middle schoolers, okay? And we're going to keep working hard. So there will be some times that we are doing math twice. Math notebooks out. Get my screen up here. Yeah.
Can you not leave on Friday? Oh, you're leaving on Friday? No, I said can you not? Because on Monday she left and we started a new lesson thingy.
Oh yeah, that was so. Oh, you were okay. Can I have? Well, let's leave that blind. We'll see. Looks okay right there. All right, so I have a video for you guys. We're going to start with our Math Antics friend here, who's so great at math. What I want to point out to you guys is that there's going to be some skills on here that are a little higher skill set, a little more on the middle school level, like 6th grade, okay? Some of these skills are still going to be our 5th grade stuff that we're working with coordinate graphs. I don't think it's bad that you guys see some of the stuff that you're going to do in middle school with it. So I'm going to play the whole video for you. The big difference is going to be, do you see this coordinate grid here?
Yeah.
Our coordinate grid that we're working with is like just this part, right?
Yeah.
That's all we're working with for 5th grade, okay? It comes down, our y-axis, our x-axis, and we have just this one part right here. In middle school, you're going to have all 4 of these parts. Okay, so that's the big difference that you'll notice in the video that we will not practice. So even though you're going to see on your video all 4 parts, we will not do all 4 parts for homework or anything. Actually, I take that back. On your vocabulary, I think they kind of show you a little bit of the 4 parts too also, okay? But nothing overwhelming, nothing you guys can't handle, okay? Some good practice. Lights, please.
Hi, I'm Rob. Welcome to Math Antics. In this lesson, we're going to learn something that's an important foundation for tons of math problems, including those you'll encounter while learning basic algebra. We're going to learn about graphing, which basically means taking mathematical relationships and turning them into pictures. Hey friends, welcome back to the joy of graphing. We're going to pick up right where we left off. You already have this nice, beautiful function right here, but it needs a friend. And we're going to do that by adding some points. So let's put the next point right here. Now all we need to do is connect those points, because they're all friends. And what do friends do? They stay connected. Oh, and look at that.
Oh my God.
That's beautiful. Well, not the kind of picture that you'd hang on your wall. Graphing just means making a visual representation of an equation or data set so you can understand it better. It's a way of helping you literally see how math works. When math is just a bunch of numbers and symbols on a page, it can be pretty abstract and hard to relate to. But graphing is like a window into the abstract world of math that helps us see it more clearly. In fact, the focus of our lesson today actually looks a bit like a window, and it's called the coordinate plane. The coordinate plane is the platform or stage that our graphing will take place on. But to understand how it works, we first need to start with its closest relative, the number line. You remember how a number line works, right? A number line starts at 0 and represents positive numbers as you move to the right and negative numbers as you move to the left. And there's usually marks showing where each integer is along the way. Now imagine cloning that number line and rotating the copy counterclockwise by 90 degrees so that the second number line is perpendicular to the first, and they intersect at their 0 points. What we have now is a number plane. It's basically like a 2-dimensional version of a number line, but that second dimension makes it much more useful. With a simple 1-dimensional number line, we could show where various numbers were located along that line by drawing or plotting points. but no matter how many points we plot, they're always on the same line. But with the two-dimensional number plane, we can plot points anywhere in that 2D area, and that opens up a whole new world of possibilities. With the one-dimensional number line, plotting points was easy. You just needed one number to tell you where to plot a point. But with the two-dimensional number plane, you actually need two numbers to plot each point. These two numbers are called coordinates because they're the same rank or order, and they work together to specify the location of a point on the number plane. In fact, that's why the number plane is often referred to as the coordinate plane. It's the stage for plotting coordinates. Coordinates use a special format to help you recognize them. The two numbers are put inside parentheses with a comma between them as a separator. So when you see 2, 5, or -7, 3, or 0, 1.5, you know you're dealing with coordinates. Okay, to understand how coordinates work, remember that our number plane is formed by combining two perpendicular number lines. From now on, we're going to refer to each one of these number lines as an axis. One of the axes is horizontal, like the horizon, which means the other axis is vertical, or straight up and down. And they're often called the horizontal and vertical axes because of that. But even more often, the axes are referred to by variable-based names. The horizontal axis is called the x-axis, and the vertical axis is called the y-axis. Why use variable names? Well, there's two good reasons. The first is that variable names are more flexible than horizontal and vertical, which relate to specific orientations in space that may not always be relevant. And the second reason is that each of the two coordinate numbers is actually a variable that relates to a specific position